formation of liquid water and hydrogen and oxygen may occur in 3 stages. So we got stage 1, stage 2, and stage 3, and we need to determine which stages are endothermic. Now, before moving on to analyze all of these 3 stages, let's first understand what is the difference between an exothermic reaction and an endothermic reaction, right? So the difference is, in exothermic reaction, the heat or the energy is released, right? Energy is released to the environment, or energy is taken out of the system, right? That is what exothermic means. So whenever there is an exothermic reaction, so the energy is taken out of the system. So it will be negative, right? The change will be negative. And similarly, for the an endothermic reaction, energy is given to the system. All right, so the change in energy will be positive. So we can say that delta E is equals to positive for an endothermic reaction, and for an exothermic reaction, delta E is always negative. Now, when we know how to figure out what's an endothermic reaction and what's an exothermic reaction, now we can move on to analyze one of these 3 stages and figure out which one is an endothermic stage, right? Now, the first stage is telling us that we got a hydrogen gas, 2 molecules of hydrogen gas, 1 molecule of oxygen gas, forming 4 hydrogen atoms into oxygen atoms, right? Now, the crucial thing here is we got here molecules, right? Stable hydrogen molecules. Why am I saying stable hydrogen molecules? Because the hydrogen is not an inert gas, it reacts, right? So you can never find an hydrogen atom alone. It will be in a pair of. So there will always be a pair of hydrogen atoms bonded covalently, forming a hydrogen molecule, which is called H2. Similar is the case with oxygen. Oxygen atom is also a very reactive atom. So it also forms a covalent bond with other oxygen atom, forming a double bond and having a molecule of O2, which is oxygen gas. And by the way, these 2 molecules are stable enough that they don't react more often, right? So to make them react, like on the products, on the reactant side, we are actually reacting the hydrogen gas with the oxygen gas. And that's a tricky thing, right? Why? Because hydrogen gas and oxygen gas are fairly stable, and they do not react more often like a very high reactive gases. They already have formed their molecules, and they are not very reactive right now. So to make them react, you need to put in energy, right? You need to put some energy in, so to make them go violent enough and then colliding to break down and to form, or to break their bonds, right? You need to provide some sort of energy in this reactant side so that they can react freely, right? So you always need to provide energy whenever the molecules are stable, right? Because they do not want to react. So if you want them to react, you need to provide energy, right? That's what endothermic reaction is. You need to put in energy to make the reaction go on, right? So we can clearly indicate that this is an endothermic reaction, right? Now let's observe closely the second stage. Now, once we got the 4 hydrogen atoms in the gaseous form and 2 oxygen atoms in the gaseous form, now they are supposed to react, right? And luckily, you do not need to provide any energy. Why? Because we only got hydrogen atoms, and hydrogen atoms and oxygen atoms alone are very violent, and they are very highly reactive, right? They are like going violent. They want to make a bond with someone, right? So you don't need to provide any energy on the reactant side to initiate the reaction. So clearly, this indicates that energy is released to the environment because the reaction goes on, right? And reaction carries so that this will be an exothermic reaction. The energy will be released to the environment. Similarly, now for the third stage, now this is tricky, right? Because both of the molecules on the reactant side and on the product side are same, but their states are different. Like this is gas and this is liquid. So it's just the process of condensation, right? So hydrogen or the water molecules in the gaseous form are turning into water molecules in the liquid form. So that's what we call condensation is, right? But is condensation an exothermic reaction or if condensation is an exothermic process or endothermic process? So let's analyze this, right? So you got gas molecules going like this way, having a lot of space between them, water molecules in the gaseous form, and they are getting to a liquid form, which is fairly close together, right? Their space is shrink down so that they convert it to liquid form, right? And that's what kinetic theory of particles suggests us, that whenever there is a decrease in energy, this means the energy is released to the environment, right? Because gases are more in energy because they got more kinetic energy than liquids, right? So liquid water will be having lesser kinetic energy than the gaseous water, right? That's why, because you are going from a higher energy state to the lower energy state, this clearly shows that this also is an exothermic reaction, right? So stage 2 and stage 3 are clearly exothermic, and stage 1 is endothermic. So we can go with the option B, that only first stage is an endothermic stage.